Next topic is stimulated absorption, spontaneous emission and stimulated emission. These three terms are very important for a laser action. We should have a good knowledge of these three terms. First is stimulated absorption. When an atom in ground state E1 absorbs an incident photon having energy h nu is equal to E2 minus E1, the energy of an atom in ground state increases by an amount h nu and it goes to excited state. This process is called stimulated absorption. This is shown in figure. For example, this is our ground state E1 and this is our higher energy state E2. When electron is in ground state, the photon falls on this and this electron absorbs energy from photon and go to higher state E2. This is stimulated absorption. Next is spontaneous emission. Normally, the excited state is unstable state where the lifetime of atom is 10 raised to power minus 8 second and the atom in excited state returns to the ground state spontaneously by releasing one photon of energy h nu. This process is called a spontaneous emission and are non-coherent. Now, if a system is in excited state, as I already told, suppose this is ground state and this is excited state E2. If our electron is in excited state, then this remains in excited state for 10 raised power minus 8 second and it loses its energy by ejecting some photon and comes down to ground state. This photon have an energy is equal to energy difference between these two energy level E2 minus E1. This is spontaneous emission. In this emission, electron is already excited state and it loses its energy by releasing a photon. Next is stimulated emission. The process by which electrons in excited state are stimulated to emit photons while falling to ground state. The stimulated emission is not a natural process. It is an artificial process to emit a photon from excited state to ground state. The incident photon stimulates the excited electrons under the condition that the electron of incident photon should be equal to E2 minus E1. In stimulate process, each incident photon generates two photons. In case of stimulated emission, if our electron is in excited state, then a photon comes from outside which have a same energy as E2 minus E1. Photon have a same energy E2 minus E1 falls on this state E2, which is already electron is in higher excited state. Then this lose this energy. This photon try to lower down the electron from higher excited state to ground state and releasing a photon. So we get two photons. One photon is from the lowering down of electrons from higher to lower excited state and one is already incident photon. These two photons have a same energy. So one incident photon gives us two output photons. This is called stimulated emission because this stimulates the emissions. This photon comes from external and stimulates the emissions. Next is pumping. The process of sending an electron from one energy level to another energy level by providing energy to that atom or molecule is called pumping. Pumping means if we have two energy levels or more than two energy levels, then the energy at ground energy level and the electron in ground energy levels can be excited to higher energy levels by providing necessary energy to electrons in the ground state energies. This is called pumping. Pumping means we are exciting electrons from ground state to higher excited states. Types of pumpings. Generally we have two types of pumping. First is optical pumping and second is electronic discharge pumping. In case of optical pumping, light is used to raise the electron from lower energy level to higher energy level. And in case of electronic discharge pumping, this is accomplished by means of intense electronics discharge in the medium and is particularly suited to gas media like helium neon laser and carbon dioxide lasers. Next is population inversion. Population inversion is very important conditions for a laser action to take place. The process of increasing population density of the atom in the higher energy state as compared to lower energy state is called population inversion. As I already told, we have two energy level E1, E2, E3. If we take three energy levels, then lower energy level is E1 and E2 and E3 are higher energy level. If number of atoms having energy E2 and E3 is more than number of atoms in having energy E1, then we get population inversion. But normally in normal conditions the number of atoms are mostly all the atoms are ground state, so there is a need of energy to raise these atoms from ground state to higher state. So population inversion is a condition in which atoms are more in higher energy state as compared to lower energy states. Next is characteristics of lasers. Lasers. First, laser light is monochromatic. Laser light is monochromatic means laser have only single wavelength. Laser light is coherent. Coherent means all the photons are in phase, and laser light is highly directional. Laser means laser light travels in a same direction, and laser light is highly energetic, and laser light have a very high energy. Types of lasers. On the basis of state of active medium, lasers can be divided into gas lasers, solid state lasers, semiconductor laser, and on the basis of state of active medium, gas lasers include mainly helium neon lasers, carbon dioxide lasers, and in case of solid state lasers we have ruby lasers, and there are also some semiconductor lasers. These semiconductor lasers occupy very less space on the basis of level of transitions. Lasers can be defined 2-level lasers, 3-level lasers, or 4-level lasers, and on the basis of output these are pulsed lasers or continuous wave lasers. Ruby laser